Trigonometry, solving trigonometric equations. If we're given an equation involving terms such as sin x, cosine x, tangent of x, or sine of a function of x, we'll try to reduce the equation into the form sin x equals k, or cosine x equals k, or the tangent of x equals k, or even the sine of a function of x is equal to k, where k is a number, and then we can take the inverse trig function. So let's look at an example. Solve for values between 0 degrees and 360 degrees, 4 sin x equals 3. Well, we start with 4 sin x equals 3 and we divide both sides by 4. Now that gives us sin x is equal to 3/4. We can now take the inverse sine. So x is equal to the inverse sine of 3/4, which is 48.6 degrees plus n times 360 degrees, or 180 minus 48.6 plus n times 360 degrees. Now we want the values between 0 and 360 degrees. So they will be 48.6 degrees, or 180 minus 48.6, which is 131.4 degrees. If we look at example 2, we've got 4 tan of 2x plus 60 degrees plus 3 is equal to 5. Well, we can start by subtracting 3 from both sides, and that leaves us with 4 tangent of 2x plus 60 degrees equals 2. We can divide all the way through by 4, and that gives the tangent of 2x plus 60 is equal to a half. So we want 2x plus 60 is equal to the inverse tangent of a half, or 0.5. Now the principal value is 26.6 degrees. So we have 2x plus 60 is 26.6 degrees plus n times 180. Now we can subtract 60 from both sides, so 2x equals minus 33.4 degrees plus n times 180, where n is any integer. So x is equal to n times 90, take away 16.7 degrees, and all the values between 0 and 360 will be x is equal to 73.3 degrees, or 163.3 degrees, or x equals 253.3 degrees, or 343.3 degrees. In part 3 we're given 2 sine squared x equals cos x plus 1. So if we start with 2 sine squared x equals cos x plus 1 and use sine squared x plus cos squared x equals 1, then sine squared x can be written as 1 minus cos squared x. So we've got 2 into 1 minus cos squared x equals cos x plus 1, or 2 minus 2 cos squared x equals cos x plus 1. And if we subtract cos x plus 1 from both sides, we get minus 2 cos squared x minus cos x plus 1 equals 0. Or multiplying all the way through by minus 1, we've got 2 cos squared x plus cos x minus 1 equals 0. Now that's a quadratic equation in cosine of x. And it factorizes to 2 cos x minus 1 times cos x plus 1 equals 0. Now, if two things multiply to make 0, one of them must be 0. So either 2 cos x minus 1 is 0, or cos x plus 1 is 0. So cos x is equal to a half, or cos x is equal to minus 1. Now if cos x is equal to a half, or 0.5, then x is equal to the inverse cosine of 0.5, which has a principal value of 60 degrees. So we have a principal value of 60 degrees and the second value of minus 60 degrees. So x is equal to 60 degrees plus n times 360 degrees, or x is equal to minus 60 degrees plus n times 360 degrees. which in the range we want means x is 60 or x is 300 degrees. If cosine of x is equal to minus 1, then x is equal to 180 degrees plus n times 360 degrees. So in the range we want, x is equal to 180 degrees. So we have x is equal to 60 degrees, or x is equal to 180 degrees, or x is equal to 300 degrees. Now there are two topics to remember when solving trigonometry equations. One is that we have some trig identities, and the other is we have certain sets of roots when we solve inverse trig functions. Now to simplify equations we can use the following identities. Sin squared x plus cos squared x equals 1, or sin x over cosine x equals tangent of x. We have sine of 90 minus x equals the cosine of x, and the cosine of 90 minus x equals the sine of x. And for finding the inverse trig functions, if theta is the principal value for inverse sine, then x is equal to theta plus n times 360 degrees, or x is equal to 180 minus theta plus n times 360 degrees. If theta is the principal value for the inverse cosine, then x is equal to theta plus n times 360, or x is equal to minus theta plus n times 360. And if theta is the principal value for the inverse tangent, then x is equal to theta plus n times 180 degrees, where n is any integer. Let's look at another example, example 2. Solve the equation 2 sin x equals cos x in the range x lies between 0 and 360 degrees. Now to solve this, we need to get the equation in terms of a single trig function. We've got 2 sin x equals the cosine of x. We can divide by 2. So sin x equals cosine x over 2. And we can divide by the cosine of x. Sin x over cosine x is equal to a half. But sin x over cosine x is equal to the tangent of x. So the tangent of x is equal to a half, which means we can take the inverse tangent. So x is equal to the inverse tangent of a half, and we can get the principal value on a calculator. It's 26.6 degrees. So the general solution is x equals 26.6 degrees plus n times 180 degrees. So if we're in the range 0 to 360 degrees, that gives us two solutions, x equals 26.6 degrees or x equals 206.6 degrees. In example 3, we're asked to solve the equation 6 sin squared x minus 5 cos x tan x equals minus 1 in the range x lies between 0 and 360 degrees. Well, to solve this, we can use the fact that tangent of x is sin x over cosine x. So we have 6 sin squared x minus 5 cos x times sin x over cosine x equals minus 1. Well, we can start by adding 1. So 6 sin squared x minus 5 cos x times sin x over cos x plus 1 equals 0. And we can cancel the cos x. So we have 6 times sin x all squared minus 5 times sin x plus 1 is equal to 0. So this is a quadratic in sin x, and we can factorise it. It factorises as 3 times sin x minus 1 into 2 sin x minus 1 equals 0. Now if two things multiply to make 0, one of them must be 0. So 3 sin x minus 1 is 0, or 2 sin x minus 1 is 0. Which means sine of x is equal to a third, or sine of x is equal to a half. That means x is equal to the inverse sine of a third, or x is equal to the inverse sine of a half. Now the principal values are theta is 19.5 degrees or 30 degrees, which means x is equal to 19.5 degrees plus n times 360, or x is equal to 160.5 plus n times 360, or x is equal to 30 degrees plus n times 360, or x is equal to 150 degrees plus n times 360. So we've got four answers: x is equal to 19.5 degrees, or x is equal to 30 degrees, or x is equal to 150 degrees, or x is equal to 160.5 degrees. In example 4, we're asked to show that the equation sin squared x plus 3 cos x sin x equals 4 cos squared x can be written as tan squared x plus 3 tan x minus 4 equals 0. And then in the second part, we're asked to solve sin squared x plus 3 cos x sin x equals 4 cos squared x for values of x between minus 180 and plus 180. Now to solve this, we've got sin squared x plus 3 cos x sin x equals 4 cos squared x, and we can divide all the way through by cos squared x. So sin squared x over cos squared x plus 3 cos x sin x over cos squared x equals 4 cos squared x over cos squared x. Now we can cancel a lot of that, and that gives us sin x over cos x all squared plus 3 into sin x over cos x equals 4. But sin x over cos x is equal to tangent of x. So we have tan squared x plus 3 tan x minus 4 equals 0. Now in part 2 we've got the tangent of x squared plus 3 times tangent of x minus 4 equals 0 is a quadratic equation in tangent of x. So tan of x all squared plus 3 tan x minus 4 equals 0 factorises as tan x plus 4 into tan x minus 1 equals 0. Now that means tangent of x is equal to minus 4, or tangent of x is equal to 1. So the principal values of x are minus 76.0 degrees and 45 degrees. This means the general solutions are x is equal to minus 76.0 degrees plus n times 180 degrees, or x is equal to 45 degrees plus n times 180 degrees. Now in the range that we want, we've got x is equal to minus 76.0 degrees, or x is equal to 104.0 degrees, or x is equal to 45 degrees, or x is equal to minus 135 degrees. And let's look at a final problem. Solve cos 2x over sin 2x is equal to 3 times tan 2x for x lying between 0 and 180 degrees. Well, to solve this, we've got cos 2x over sin 2x equals 3 times tan 2x. And if we multiply by sin 2x all the way through, we get cos 2x equals 3 times tan 2x times sin 2x. Now, if we divide all the way through by cos 2x, we get 1 equals 3 tan 2x times sin 2x all over cos 2x. And we can write that as 1 equals 3 times tan 2x times sin 2x over cos 2x. But sin 2x over cos 2x is equal to tan 2x, and so we end up with 1 equals 3 times tan 2x times tan 2x, or we can write that 3 times tan squared 2x equals 1. Which means tan squared 2x is equal to a third, or if we take the square root of both sides, we get tan 2x is equal to plus or minus 1 over the square root of 3. So if we take the inverse tangent, we get 2x is equal to the inverse tangent of 1 over root 3, or 2x is equal to the inverse tangent of minus 1 over root 3. And the principal values of 2x are 30 degrees in one case and minus 30 degrees in the other. So our general solutions are 2x is equal to 30 degrees plus n times 180 degrees, or 2x is equal to minus 30 degrees plus n times 180 degrees. Now if we divide through by 2, we get x is equal to 15 degrees plus n times 90 degrees, or x is equal to minus 15 degrees plus n times 90 degrees. Now if we're staying in the region 0 to 180 degrees, that gives us x is equal to 15 degrees or 105 degrees, or x is equal to 75 degrees or 165 degrees.